Welcome back. And so in this video, we're just going to do a couple quick calculations with molarity and molality to get used to working with them. And so I'm going to first do a calculation with you all, and then I'm going to let you all try to do a similar calculation on your own where I'll have you pause this video. And so initially here, we're going to start with a problem where it asks us to calculate both the molarity and the molality. And I've given the definitions for each of those below. And so we're told that we have an aqueous solution of sodium chloride, and it's made using 112 grams of sodium chloride. And so the first thing I'm going to do is I'm going to write down what I know. So I have 112 grams of NaCl, and that's diluted to a total solution volume, focusing on the fact that this is a solution volume of 1 liter. So we have solution volume equal to 1 liter. And then I want to calculate the molarity and the molality. And the last piece of information that we're given is that the density of the solution, so I'll put density of SOLN for solution, is 1.08 grams per mil. And so if I look at my definitions for both molarity and molality, I can see that, molality depends on liters of solution, if it lets me highlight. And I actually already have my solution volume, so I don't have to solve for that. We also see that molarity and molality share that same numerator of moles of solute, and I see that I don't have moles of solute, but what I do have is a mass of solute. And so I'm going to probably end up using this in order to calculate that. And then finally, the last piece of information is going to be that kilograms of solvent. And so right now, I have a volume of solution and a density of solution. So I'm probably going to use these two in tandem in order to calculate the kilograms of solvent. And so the first thing I'll do is I'll actually just end up calculating my moles of solute. So if I have a mass of solute, the way I'm going to go from mass, I didn't switch off my highlighter. The way I'm going to go from mass to moles is just going to be using the molecular weight here. And so I'm going to take my 112 grams NaCl. I'm going to divide that by its molecular weight, and in this case, that's 58.44 grams per 1 mole. And I'd get that I have 1.92 moles of NaCl. And so right off the bat, now that I have that, I now have my moles of solute and my liters of solution, so I can calculate the molarity. So the molarity is equal to my 1.92 moles NaCl over my 1.00 liters of solution. I get that this is 1.92 molar. So I've solved half of my equation here. For the second half, in order to get that kilograms of solvent, the easiest thing to do first is to just find out how many kilograms of solution I have. And remembering that density in terms of grams per mil is equivalent to the density in terms of kilograms per liter, I can just take this solution volume of 1.0 liters of solution, multiply that by the density of 1.08 kilograms per liter of solution. I cancel out my liters of solution in both in the numerator and the denominator, and I get that the total mass of my solution should be 1.08 kilograms or 1,080 grams. And that's the mass of solution. And we know that the solution is composed of both the solute plus the solvent. And so the mass of solution must be the sum of those as well. And so if I'm trying to solve for mass of solvent, I just have that, mass solvent, SOLV, must just be equal to the mass of solution minus the mass of my solute. And so I can just take that 1,080 grams of solution, subtract by mass of NaCl, which is 112 grams, and I'd get that my mass of solvent must then be, 968 grams, or 0.968 kilograms. And so I now have everything I need to calculate my molality. So I have little m is equal to 1.92 moles divided by 0.968 kilograms. And I get, in this case, that the molality here is 1.98 molal. And so you can see that molarity and molality are pretty similar, but they just differ, by, in this case, around, I guess, 10%-ish. Almost 10%, a little bit less than 10%. So, what we realized in this slide is that when we're doing these molarity to molality type of problems, really the only difference between them is that to convert from one to another, we end up needing the density of solution. So we can go from volume of solution to mass of solution, and then finally to our weight of that solvent. And so, just as another practice, let's assume we have a 1.5 molar solution of potassium iodide, and it has a density of 1.04 grams per mil. How can we calculate the molality? And so if we do this part right here that just says easiest to assume 1 liter of solution and work from there, we can say that we have a 1.5 molar solution, which is equal to 1.5 moles per liter. We multiply that by our assumed volume of 1 liter just to make the math easy. And we know that the solution has 1.5 moles of potassium iodide. The next thing we can do is then figure out what is the total mass of solution. So we're going to take our 1 liter and then multiply that by that density of 1.04 kilograms per 1 liter. And we get that in this case, our mass of solution is 1.04 kilograms of solution. And now we just have to do that last bit of the solve where we take our, in this case, 1.04 kilograms of solution, or 1,040 grams of solution, and we subtract out our mass of potassium iodide. And, very nicely, we have that 1.5 moles of potassium iodide we have. And so we can just take that, multiply it by the molecular weight of potassium iodide, which in this case is going to be 166 grams per mole. We'd see that our total mass here is 249 grams. And so we subtract 249 from this. We get that the total weight of our solvent is then 791 grams of solvent. And then we just plug in everything we have. So we'll take our number of moles of potassium iodide, 1.5 moles, as we have here, moles of solute. We divide that by our kilograms of solvent, 0.791 kilograms, and we get that in this case, our molality is 1.90 molal. So just another chance to show how to do these types of conversions. And so the last thing we'll do with this presentation is I'm going to give you a question. And I want you to read through this question, pause the video right here, and try to solve this. And so what we're trying to do is that we're looking at a solution of potassium nitrate is made by diluting 150 grams of the salt. So we can write down what we know. 150 grams of potassium nitrate. It's diluted to a total solution volume of 1 liter, so not that different from the first slide we had here. And we know that the density of solution is equal to 1.2 grams per mil, or 1.2 kilograms per liter. And so I'm asking you, what is the molarity and the molality of this solution, given that the molecular weight of potassium nitrate is 101.1 grams per mole? So I'll let you pause the video here and then solve this, and then you'll come back. All right, welcome back. And so the first thing I want to do here, knowing that molarity and molality both depend on moles of my solute being potassium nitrate, I'm just going to figure out how many moles of that I have. So I'm going to say that my moles solute must just be equal to 150 grams potassium nitrate divided by its molecular weight of 101.1 grams per mole. And this gives me that I have 1.48 moles of potassium nitrate, my solute. Now, what I can do is I'm going to solve for each part of the denominator for molarity and molality. And so for molarity, we know that we're looking for liters of solution. We actually don't have to solve here. We know that's 1.00 liters. And so we can calculate molarity as such. We have molarity is equal to 1.48 moles over 1 liter, giving us 1.48 molar. The next thing we're going to do is then calculate our molality, and that starts by figuring out how much total mass we have of solution. So we're going to look at mass of solution, and then from there go to mass of solvent. So we'll take our volume of 1.00 liters, we'll multiply that by the density, 1.2 kilograms per liter, just as we've done on the last two slides. That gives us 1.2 kilograms or 1,200 grams of solution. We can then go ahead and subtract our mass of potassium nitrate from before, so minus 150 grams KNO3. We can then do that calculation. That gives us that the mass of just our solvent must be 10,050 grams solvent. And with that, we can then solve for our molality, where we say molality is equal to those 1.48 moles divided by, in kilograms, the mass of our solvent, 1.05 kilograms. We go through that calculation, and we get that this is 1.41 molal. Once again, seeing these are two pretty similar concentrations, but they just differ a little bit based off of how we do this calculation. And so in the next set of videos, we're just going to talk about more of those different types of ways to calculate concentration.